Hello, my name is Scott Minnick, and I'm a meteorologist with the National Weather Service office in Wakefield, Virginia. This presentation was put together for the purpose of sharing a winter outlook for the Wakefield forecast area. We will briefly overview fall 2013 before jumping into the winter outlook and what impacts we can expect. Special thanks to Larry Brown, Mike Montefusco, and Jeff Orrock for their help with this presentation. First off, we'll take a look at what has occurred during meteorological fall 2013 and the conditions leading into the upcoming winter. The large image displays the percent of normal precip over the past 90 days. While the legend may be difficult to see, the entire region received anywhere from 25 to 90% of normal. This includes a widespread beneficial 1 to 3 inches that fell November 26th to 27th with no tropical system this year. Southern portions of the eastern Virginia Piedmont received the least rainfall with only 25 to 50% of normal, while parts of central Virginia received the most with up to about 90% of normal. More specifically, Richmond recorded 86% of normal rainfall this fall, only 62% until that November 26th to 27th rain event, and Norfolk coming in at 69% of normal rainfall this fall. For Richmond, 68% of the total rainfall occurred on just 4 days between two two-day events. The result of below normal precipitation was the introduction of D0 or abnormally dry drought conditions into much of central Virginia. This can be seen in the latest U.S. Drought Monitor, located in the lower right image, issued on November 26th. Drought conditions will likely improve due to the recent rainfall. Richmond still remains well above normal this year, running a surplus of 7.46 inches. Norfolk, however, is running a slight deficit at just 2.15 inches below normal. The first thing we'll look at is the current El Niño Southern Oscillation, or ENSO, phase, as it is a big driver in winter weather. Niño 3.4 represents a section of the Pacific Ocean that we look at sea surface temperature anomalies to determine El Niño versus La Niña. Quickly, El Niño is represented by a sea surface temperature anomaly greater than plus 0.5 degrees Celsius, and La Niña is represented by a sea surface temperature anomaly less than negative 0.5 degrees Celsius. The range from negative 0.5 Celsius to positive 0.5 Celsius is called ENSO neutral. For more specific information on ENSO, please navigate to the link on the bottom of the slide. The latest model guidance provided here by the International Research Institute for Climate and Society shows good model agreement with keeping ENSO neutral conditions through the winter and into the spring. This is similar to what we experienced last winter. To put it into probabilities, the image on the right shows high probabilities through the winter for neutral conditions to continue. The latest ENSO discussion from CPC also states that ENSO neutral is expected into the Northern Hemisphere spring 2014. So combining all the model data and expert opinions, there is high confidence that ENSO neutral conditions will occur throughout the winter. However, high confidence in ENSO neutral produces low confidence on exactly how the upcoming winter will pan out, as there is no strong climate indicator. That means we have to focus on short-term climate drivers that are much more difficult to predict outside of a week or two. One of the most prominent teleconnection patterns in all seasons is the North Atlantic Oscillation. The NAO combines parts of the East and West Atlantic Ocean patterns for the winter season. The positive phase of the NAO reflects below normal heights across the high latitudes of the North Atlantic and above normal heights over the central North Atlantic, the eastern United States, and western Europe. The negative phase reflects an opposite pattern of height anomalies over these regions. Both phases of the NAO affect the location and intensity of the jet stream and the resultant storm track. Strong positive phases of the NAO tend to be associated with above average temperatures in the eastern United States and across northern Europe, and below average temperatures in Greenland and oftentimes across southern Europe and the Middle East. The NAO is highly variable during the winter seasons due to drastic differences in temperatures between the poles and mid-latitudes. It is very difficult to forecast outside of 1 to 2 weeks. Now we'll take a look at how the NAO affects the Wakefield forecast area. First, we'll look at temperatures. Focusing on Richmond, the graph on the left displays the NAO index from December to February each year since 1950, which is represented in red dots, compared to temperatures. You can see there is a correlation between a negative NAO being cooler than average and a positive NAO being warmer. In fact, research also suggests that the correlation is better than that of ENSO. The chart on the right is a display of positive NAO and negative NAO temperatures compared to normal. While the trend line shows a correlation, there is still some variability. Using the same concept, there is a fairly strong correlation with increasing snowfall with negative NAO winters and a decrease with positive NAO winters. In fact, per the graph on the right, there is an increase in snowfall at all stations during a negative NAO. The opposite is true during a positive NAO. Unfortunately, as stated before, the NAO is highly variable and difficult to forecast outside of 1 to 2 weeks. It is also not unusual to experience prolonged periods, possibly up to several months, of both positive and negative phases of the pattern. Displayed on top is the current ensemble NAO index forecast. As you can see, there is a fair amount of model spread into mid-December with runs of the ensemble displaying either a positive NAO or a negative NAO. The mean, or the blue solid line in the bottom image, hovers right around a neutral NAO. This gives us little indication on how warm or cold winter will begin. Future forecasts can be found at the Climate Prediction Center's website, located at the bottom of the screen. The lack of strong climate signals and patterns that often give us clues as to what the season will bring has proven quite difficult for forecasting this winter. The result is a large swath of equal chances for above, below, or normal temperatures and precip. The Climate Prediction Center focused on recent climate trends to get insight about what might arise. The past 15 winters have not been much different than average for all the winters between 1981 and 2010. Across parts of the north, there has been a small tendency for wetter conditions. Across parts of the south, the trend has been for slightly less precipitation. For temperatures, the trends have been even less significant, with only some small areas being slightly warmer than average. To note, Richmond and Norfolk receive right around 21% of their annual precip during the winter season. In summary, ENSO-neutral conditions will prevail, giving us no strong climate indicator this winter. That forces us to watch short-term climate features such as the North Atlantic Oscillation. It also reduces the predictability of the winter, resulting in equal chances for above, below, or average temperatures. And with that, we will wrap up this presentation. Thank you for viewing, and if you have any questions or comments, please feel free to get in touch with any of the people listed. I have also included some important links for anyone to follow the latest winter and climate information. Thanks again, and be safe this holiday season.